All right. Welcome, guys. This is from Wrestler Labs. So today we'll be exploring how to use Microca Origin to generate publication quality images of your data. Maybe after molecular docking or molecular dynamics, you want to generate good images, publication ready. So ride along with me. So let's do some data exploration. Um, So here you have file. You can uh, create new file format. So Origin takes different kinds of file. So depending on the type of file you want to load, you create that kind of file format. So you can create a worksheet or an Excel or a graph or even a matrix, depending on the type of data you want to load. Now, for now, most of the things we are going to do just stay on worksheet. So, okay. So you see, worksheet is just like similar to Excel. You just have rows and columns, and you can extend it depending on um on what you want. You can actually insert new columns, keep extending it to the right as long as you want, obviously. Okay, so that's one. Second thing, you can also open uh let's say a new project or whatever, maybe a new project or a text file or a matrix, whatever. So you can open files. Yeah. So then obviously you can save this project. Yeah. Then you can also save the project as if it's a new project, if it's an ongoing project or whatever. So then most importantly, import. So this is where you can import various file types. So single ASC, SC2, that's basically your tab separated file, your dat file and whatever. So if you have multiple files that you want to plot together, and your multiple ASC2 will be a good file for that. We're going to explore it now. Okay, so that's basically that. So let's start. We want to start from a single file. We'll make the plot. Then we move on to multiple files and on and on and on. So follow me. So we're going to load a single file first. So here it will just be a single tab separated file. So I'm going to load it. It's around 10 megabytes, so it will take a few seconds to load. But it's quite easy, so relax. We are almost there. Good. It's loaded. Fine. So we have an extra column. I think I might want to delete that. Then we have also, so you see it's two column, the frame. So this is the RMSD from a simulation, molecular dynamics. So we have the frame, it's essentially the time, and then the RMSD, the second column. So we're going to edit something. In the first rows, we have an extra uh, words that are not necessary. So we're going to delete that. Then we might also rename this depending on what you want. So we might just call it RMSD, and we have it here. So to make the plot, you select all the columns you want to plot, and then you click plot. Obviously, we want a line plot. You can also look for scatter plots if you're trying to fit a line, which we're going to discuss later. You can also make bar plots. So now there's so many kinds of plots. So this is line plot. Then it shows up. So this is the RMSD with respect to frame or time for this particular simulation system. So now that we have this, how do we beautify this image? How do we make it actually publication ready? Yeah, because the way it's looking now, it's good, but not good enough, right? So, so first of all, let's address the axis. So here we know here will be a simulation time. Okay, obviously, let's make it in nanosecond. Then we are going to make it bold, give it a very high size, and click OK. So for the y-axis, because this is RMSD, we can make it in Armstrong. Same way, make it bold, then give it a very high size. You can also shift it a little so that it doesn't overlap. Now, for the other, for the ticks, you can also make it bold, bring it to 26. Yeah, and that's for the left axis. For the bottom axis, make it bold, bring it to 26, and then okay. So that's what you have. It's becoming beautiful. Right now, you can also see that my simulation time is still not in nanoseconds. It is in frames, 500,000 frames. Now, for this particular simulation, it is saved in such a way that 1,000 frame is equals to a nanosecond. So we're just going to edit that. It's very easy. You click on the axis and it pops up here again. It's going to say divide by a factor. So I'm just going to add 1,000 here and then okay, that's beautiful. See, we now have it in nanoseconds. You have RMSD, that's fine. Last thing we want to do is this legend, we might want to beautify it a little bit. So it's also here. You can say make it bold, then increase the size to 28, then maybe give it a just continue. So we want to beautify our legend. So we have made it bold, give it 28, and then we want it to have a shadow. Fine, that is beautiful. We can also adjust the color for our plot. So if you don't like everything here is black, no, it's not good. So click on the color and then say, can you give us magenta? And then can you also increase the width to like 2, like, and then okay. So this is a beautiful plot, RMSD, with respect to time for publication. This plot is of high quality. You can embed it anywhere and it will retain its size, its resolution. So what do we do? We want to save it. So you will just click outside of the plot, export this page, and then I'll need to find where my folder is, and that's very simple. So this is where I am. Then I can choose the file format. Most likely I save in TIF. You can save in PNG or whatever you want. So that's one. And then here we go. So um takes a little bit of time to save depending on the quality of the image, but generally it's just very fast. Yeah, it's there, it's saved. Good. So that was one thing. The other thing there is, what if we want to manipulate the size of the plot? Maybe this size of the plot is too small for us. What do we do? So we can click here again and look for properties and adjust it. So basically, so I can make here 33, make here 11. It's usually my sweet spot. You get that? So can click OK. Okay, that's too bad. I missed it, so I'm going to try again. Good. Yeah, so this looks a bit because some part of the plot is cut out, so it's all good. So you keep adjusting it based on what you want. So I think I can actually make it 28. And then I think I have everything under lock and key. So this is an extended graph. Very beautiful. So because sometimes you want to extend your graph in order to catch the little details, right? So how do we save this out? Exports. And this time around, we're exporting the image again. But since we changed the properties of the image, we have to tick show export options. And then maybe we'll call it plot 2. Yeah, so if we click save, then it will pop up and ask us, oh, what dimensions do we want to save it? And then we remember the exact dimensions um, that we've used before, which is 8 and 28. So Can now save it in this same dimension, and that is all. So you can manipulate the dimension depending on the size you want your image to to bear. That's one thing that is so beautiful about Origin. Good. So we're going to do another plot. This time around, let's look at what if we want to load more than one file. How do we go about it? So we're going to create a new worksheet so that we're not working on the same thing. Good. Now, then let's now import multiple SC2. Good. Let's go a little bit back because I need some files. Okay. All right, all right, all right. We are almost here. 1 minute. Windows. Good. Users. Yeah. Okay. So my documents. I'm looking for something very simple. Believe me. Something very, very simple. So that it doesn't take us so much time. But I think I found something. But so maybe I need these two files and I want to put them together. So first of all, I select them. Then I add them here just to make sure I selected the files I need. And then once you select files, it arranges them in alphabetical order. So take note of that. But sometimes when it imports this file, it doesn't import them with the name you saved them. So you must be careful to note the alphabetical order in which you loaded the files. Okay, and I click OK. See, it's loaded. And it doesn't tell me whether it came from the first one or second one. So uh, that's why I asked that you take notes of the alphabetical order. So, so now the most important thing here is that it loads the files one after the other. First two columns, first file, the next two columns, the next file. So that is what is beautiful about it. So what do? I already know that this belongs to compound 37. Okay. Then now, now one other challenge here is that it only gives one X and assumes that every other thing is a Y, which is not true because the first column is X, second column is Y for the first data. And for the second data set, the first column should also be X and the second column should be Y. But that's not what it says. So we need to edit that, right? So for this, we need to change it to an X and then delete this extra word here. And then also delete this extra word here. And remember that this is C47. Then we click OK. Fine. Select everything. Make your line plot. It comes out very, very beautiful. So the same way we explained the last time, you you can increase the thickness of these lines, and then you can make all the necessary edits to make it more legible to the extent that you desire, and you export it, and that is all. So this is single and multiple files, right? Very, very easy. Now, what if we want to plot, for most of us that are very used to molecular dynamics, what if I want to plot a correlation matrix, the matrix of the correlation between the different residues. Good. So I'll create a new file. This time around, I need a matrix, right? Good. So it will bring up a new kind of data set configuration to allow me load my file. Sorry. Then I will I will go and get my file to load it. So my downloads, loads. So I have a correlation matrix here. It loads automatically. You know the identity of a matrix. There's always a diagonal. You can see it here, 111. So that's an identity of matrix. So if I have this, now one other thing to note about a matrix is that there are a few configurations you can make. For example, this matrix, I can decide, uh, it's not I can decide, I know how many residues are available in this particular protein. Now, because if I make a plot directly like this, it will not be able to fit into the axis that the plot is going to give me. Now, look at what I'm saying. So if I decide to plot a matrix, so it's going to label it from 0 to 10. Meanwhile, this matrix is generated to account for all residues of the protein. So you see, it doesn't make sense. This protein is more than 10 residues. The reason is because it didn't adjust the size of the matrix with respect to the residue number. It just adjusted it with respect to a fixed factor. So we can actually correct for that by uh, making edits. So we can set the dimension of of our data set depending on the number of residues that is available in our protein. So you can see here 389 is the number of residues in our protein. So 389, and then we'll click OK. So the next time we run a correlation plot, it actually gives us the ideal number of residues that are available in our protein. Then we can follow through just like every other one, and then try to label it and make it look good, right? So for here too, you can make it whatever you want, 20, make it bold, and then make it beautiful. After that, you can save it. These are very, very high resolution pixel images. They don't degrade, they are very great. Now, one other thing that might be interesting to you is, what if you have a scatter plot and then you want to fit a line to it? How do you intend to do it here? So if you have a scatter plot and want to fit a line, so let's define um, a new set. Let's also choose a worksheet, and then I'm going to import, maybe this time around, a CSV file. So it's just random data of X and Y axis. Now I'm going to run a scatter plot on it. Um, Scatter plot. So this is actually a very terrible data, as you can see. I mean, very terrible data in terms of scatter. It doesn't look like there is a trend. So I decide to do whatever I want. I want to do with it. That's crazy, right? Okay, so well, it's very easy. I can first of all decide, oh, for the tools, let's try a linear fit. Okay, so see, it found a fit, and it gives me all the matrices of the fit, or the characteristics of the fit. The R is very, very poor because there is literally no correlation. P-value is crazy, the standard deviation is crazy. So I just wanted to show you this because you can apply various kind of fitting for your plots. You can fit it anyhow you want. So there are many other features that are available here. You can make plots with error bars. You can make several kinds of plots are available, as you can see here. But this is just an introduction. Maybe in another separate video, we can actually settle down to go into more advanced functions in Origin. Now, currently in our lab, we're also interested in most of our plots, we are doing it in Python. But we believe that knowing about Origin is still very crucial. Most times I still run back to Origin to do some basic checks and generate some high quality images that I need for specific purposes. That is where science becomes beautiful. Because if you know them all, then your choices, your preferences can explode. You can decide to do whatever you want to do because you can play around. So I hope this has introduced you to Origin. If you need the software, we can make it available. You can comment on you can send a message to us, or you can send us a message via our email. I'll send you the software. You can install it and begin or continue your scientific journey into data analysis, computational drug discovery, and then preparing beautiful images for your publication or presentation, whatever it is. Thank you so much. See you again.